Picture this. You're winding down after a long day, maybe even celebrating a successful release with your team. Everything seems perfect, until it isn't. It's just past midnight. Your team has pushed a new release. The deployment pipeline glowed green, smoke tests passed, and you all logged off, confident that everything was under control. Then your phone buzzes. Pager duty alert, another, and another. The notifications keep coming, each one more urgent than the last. The regression test suite is failing, massively. The dashboard that was green just hours ago is now a sea of red. You scramble to your laptop, heart pounding. Test after test is red, not because the app is broken, but because a developer changed a button's ID from toe. A trivial UI tweak, but now every test that logs in fails at step 1. All that effort undone by a single, seemingly harmless change. The application works fine for users, but your automation is lost, looking for a signpost that's vanished. The scripts are searching for something that no longer exists. This is the brittle nature of traditional UI test automation. One small change, and the whole structure comes crashing down. We call it test flakiness, but often it's just the reality of evolving applications. Software is meant to change, but our tests struggle to keep up. We spend hours crafting locators, building frameworks, integrating with CI/CD, all to ship faster. We invest in automation hoping it will free us from repetitive work. Yet, a single attribute change can invalidate days of work. All those carefully written scripts, suddenly obsolete. Maintenance becomes a never-ending chase after UI changes. Every sprint brings new tweaks, and every tweak means more broken tests. We write tests to save time but end up fixing them constantly. The cycle feels endless and the frustration grows. The tools meant to accelerate us become anchors. Instead of moving faster, we're weighed down by maintenance and technical debt. The dream of continuous testing feels distant when you're up at 1 a.m., updating locators just to get the build green. The promise of automation starts to feel like a burden. It's a pain point every tester knows. The stress, the late nights, the feeling of fighting a losing battle against change. We've tried better locator strategies and stricter standards, but the core problem remains. Our tests are too tightly coupled to a UI that's always changing. No matter how clever we get, the foundation is shaky. There has to be a better way, a way to break free from this cycle and finally let automation deliver on its promise. Imagine if our automated tests could adapt and evolve on their own, just like living organisms responding to their environment. What if our tests could adapt? Instead of simply breaking when a locator changes or a web element is updated, these tests pause, analyze the situation, and intelligently find the right element anyway, without human intervention. That's the promise and power of self-healing test automation. A new era where tests can repair themselves in real time. It leverages advanced fallback mechanisms, machine learning, and artificial intelligence to handle locator failures with remarkable intelligence and precision. Rather than relying on a single fragile attribute, self-healing automation builds a robust context-aware profile, taking into account tag names, visible text, element position, and even relationships to neighboring elements. When a locator fails, the system investigates, searches for the most likely match, and allows the test to continue, while logging the event for later review and analysis. This proactive approach transforms disruptive failures into actionable feedback, ensuring that development and deployment can keep moving at high speed, even as applications evolve. In today's fast-paced world, self-healing is the essential buffer that modern teams need to keep up with rapid change, reduce maintenance, and deliver quality software faster than ever before. How does self-healing work? It's a layered investigation. When a locator fails, the self-healing engine tries fallback locators first. If those fail, it uses machine learning to analyze the DOM, looking for elements with similar text, structure, or position. Visual AI adds another layer, comparing screenshots from previous runs to find visually similar elements, even if the code has changed. All clues are scored for confidence. If a candidate passes the threshold, the test is healed and continues, with the action logged for review. This process keeps tests running, even as the UI evolves. It's automation that adapts, not just reacts. Self-healing shines in fast-paced, agile environments with frequent deployments. When UI changes are constant, brittle tests can block the pipeline. Self-healing absorbs minor UI tweaks, keeping the pipeline flowing. It's especially valuable for apps built with dynamic frameworks like React or Angular, where static locators break easily. Tools like Omniit.ai are built for this, capturing rich data about elements and using AI to heal tests in real time. As test suites scale, self-healing reduces maintenance overhead, letting QA focus on new scenarios instead of endless fixes. It's the key to sustainable, large-scale automation. With self-healing, teams can finally keep up with the speed of modern development. Self-healing isn't perfect. It can create false positives, healing a test by picking the wrong element, letting bugs slip through. Semantic drift is another risk. The AI might match an element that looks the same but behaves differently. Over-reliance can breed complacency, letting technical debt pile up as broken locators go unaddressed. Self-healing engines need careful configuration and regular review. Set thresholds too low, and you get false positives. Too high and real issues are missed. It's not a set-and-forget solution. Use it as a safety net, not a crutch. Skill and judgment are still essential. To succeed with self-healing in your automation strategy, it's important to follow a few essential guidelines that will help you maximize benefits while minimizing risks. These best practices are designed to ensure your automation remains reliable, efficient, and easy to maintain as your projects grow. Treat self-healing as valuable feedback, not just a silent fixer. Review every healing event carefully, analyze the root cause, and update locators or test logic as needed. This proactive approach helps you catch underlying issues early and keeps your tests healthy. Don't blindly trust every heal. Always keep a human in the loop, especially in the early stages. Human oversight is crucial for validating changes, learning from patterns, and preventing automation from masking real problems. Start small, pilot with a subset of tests, tune your healing thresholds, and gradually expand as your confidence grows. This controlled rollout helps you measure impact, adjust settings, and avoid widespread issues. Don't abandon good automation practices. Continue to write clean, maintainable code, use stable and meaningful locators, and collaborate closely with developers to ensure your UIs are testable and robust. Use page object models to make updates easier, and to centralize locator management, which simplifies maintenance as your application evolves. Remember, self-healing should be your backup, not your first line of defense. Rely on it for resilience, but don't let it replace solid test design. The more robust and well-designed your tests are, the less you'll need to rely on healing. Make every intervention meaningful, and let self-healing enhance, not replace, your automation quality. The pace of software development is only accelerating. Brittle automation is a business risk. Self-healing is a smart safety net, not a silver bullet. It keeps tests resilient as UIs evolve, freeing engineers to focus on higher-value work. Success comes from thoughtful implementation. Start with pain points, pilot with tools like Omniit.ai platform, and review healing reports. Foster a culture where self-healing assists, not replaces, sound engineering. Embrace self-healing wisely and you'll build robust, adaptable pipelines for modern development. Don't let broken locators break your flow.